this module, we'll be focusing on the use of automatic sprinkler suppression systems in mid-rise timber buildings. In this presentation, we will cover the risk reduction benefits of sprinkler systems, the specification requirements for different building heights, and we'll also examine a number of different ways to improve efficiencies of the systems, including the use of residential sprinkler heads and monitored valves, the selection of appropriate system materials and processes, and also the importance of protection of voids and concealed spaces. In terms of the fire engineering principles approach for mid-rise timber buildings, arguably the most important requirement is the need to provide automatic fire sprinkler systems. These need to be installed in accordance with NCC specification E1.5 throughout the building, including any parts of the building that are not of timber construction. This requirement, in conjunction with other fire safety measures, dramatically reduces the risk in the unlikely event of a fire in a mid-rise timber building. The risk is in fact reduced to below that of other forms of construction, such as concrete and steel, which do not require sprinklers in buildings up to 25 metres. So mid-rise timber buildings are in fact safer for occupants and firefighters from a fire risk perspective. Historic records and statistics over more than 100 years have shown that automatic fire sprinklers have been the most reliable fire protection system, with most estimates placing reliability above 90%. They are particularly effective because of their high reliability, combined with early automatic suppression of fires, without any need for human intervention. Specification E1.5 allows sprinkler systems to be designed in accordance with 3 Australian standards: AS2118.1, Automatic Fire Sprinkler Systems, General Requirements; AS2118.4, Automatic Fire Sprinkler Systems, Sprinkler Protection for Accommodation Buildings not exceeding 4 stories in height; AS2118.6, Combined Sprinkler and Hydrant Systems in multi-storey buildings. The scope of AS2118.4, however, excludes offices and is limited to residential accommodation buildings not exceeding 4 stories in height. Therefore, most mid-rise timber building sprinkler systems will be designed to comply with AS2118.1 or AS2118.6. There are also opportunities during the design process to incorporate features that can enhance the effectiveness of an automatic sprinkler system and simplify ongoing maintenance. Sometimes there is a related cost, but often the cost is quite minimal, whilst the benefits substantial. A few examples of effective approaches are as follows. Both AS2118.1 and 2118.6 allow the use of appropriately listed residential heads in residential building SOUs and associated corridor areas. These heads have a more rapid response than standard heads and are more likely to suppress rather than control a fire, thus reducing the risk to occupants within the sole occupancy unit of fire origin. It is recommended that where appropriate, residential heads should be specified, so talk to your services engineers. It makes sense to use them, as they enhance safety for little cost penalty. False ceilings are also a logical and practical approach with sprinkler systems. If sprinkler pipes are run above a fire-rated ceiling system, the ceiling will need to be penetrated by the sprinkler heads, potentially compromising the fire performance of the ceiling. It is therefore recommended, whenever possible, to utilise a false ceiling, running the pipes in the void. The penetrations for these sprinkler heads need only then penetrate the non-fire resisting false ceiling. This detail also provides flexibility for lighting systems such as downlights and other surfaces. It also dramatically assists in reducing the future risk of any alterations or service additions penetrating the fire-rated ceiling system. It is also recommended that monitored stop valves be provided on each floor, though this isn't a requirement of the standard. This will allow isolation of building areas and enable sprinkler protection to be maintained throughout the remainder of the building, if work needs to be undertaken on part of the sprinkler system or on a certain building level. If the valve is left closed upon completion of the work, the building owner can be alerted to ensure the error is quickly corrected. Thus, the time periods and extent of areas where sprinkler protection is unavailable are minimised. This is a feature that should certainly be discussed with the building developers and owners. The progressive installation of monitored valves during construction can also be used as part of the strategy to address fires during construction by facilitating the progressive commissioning of the sprinkler system. Selection of materials for use on the sprinkler systems is also an important consideration. Clearly, if materials that require hot works can be excluded or reduced, then this dramatically reduces the fire risks during construction or ongoing maintenance. The use of CPVC, chlorinated polyvinyl chloride piping for sprinkler systems, can also reduce the need for hot works. However, these systems use adhesives which need time to cure. And as such, if the pipework needs adjustment, the system will be unavailable, potentially overnight whilst the glue sets. Another option that might be considered is the use of mechanical joiners for metal pipes that avoid the need for hot works if components need replacing or modifying. So as you can see, there are also a number of materials options that can be discussed with your services engineers. Concealed spaces within fire-protected timber elements greater than 200 mm deep generally require protection. Where these voids include elements such as beams, the void depth is measured from the soffit of the beam. Where open web beams, trusses, or similar elements are included in the cavity, consideration may be given to providing protection where the distance between a ceiling and the bottom chord is less than 200 mm, since open webs will not obstruct the sprinkler discharge to the same extent as solid beams. So in summary, automatic fire sprinkler systems are one of the key safety features for mid-rise timber buildings. Their use reduces the risk from fires below that of other forms of construction. Residential sprinkler heads should be specified wherever possible. Also, where possible, use a false ceiling, running the sprinkler pipes in the void. This void can then be used for placement of downlights and running of cabling. Provide monitored stop valves on each floor. Consider piping materials and processes that do not require hot works, such as CPVC and/or mechanical joiners. Finally, consider sprinkler protection in voids and concealed spaces. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.